Um, Welcome to Project 5. So I just wanted to briefly go over some of the background behind Project 5 and help you pull the relevant data for the different research questions. So this project is all about sensitivity and specificity for diagnostic tests. These are real terms used for talking about diagnostic testing, whether it's testing for COVID, doing blood tests, any sort of diagnostic testing, you have sensitivity and specificity. So the general idea, a diagnostic test is used to diagnose a disease, and the test can either be positive, say you have the disease, or negative. So for sensitivity, key thing is that the sensitivity is the rate at which the test accurately recognizes positive cases. And it is calculated by looking at all of the people who actually have the disease and then finding the percent of those people who test positive. So for sensitivity, the population that we're looking at is specifically the people that actually have the disease. And then what sensitivity is it's the number who test positive divided by those that actually have the disease. So this is sensitivity. So anytime we're talking about sensitivity, we're only focusing on the people who actually have the disease. On the other hand, if we look at specificity, we're looking at the rate at which the test accurately recognizes negative cases. So in this case, you look at all of the people that do not have the disease and then find the rate at which those people test negative. So for specificity, the population is the people who do not have the disease. Specificity is the number of that test negative divided by the number that do not have the disease. So if we go back and look at the research questions that we had, so scrolling back up, now that we have sort of the vocabulary, our two research questions we are looking at are, number one, what is the specificity of the new Statsville Pharmaceuticals COVID-19 diagnostic test? So here we are looking at specificity for question number one. So specificity, our population was those who do not have the disease. So for question number one, we are looking at a population of the people who do not have the disease. For question two, we are looking at sensitivity. So our population here is the people who do have the disease. So these are going to be two key statements to have. I'm going to slightly shrink the things on the side. So again, sensitivity, we're looking at the number that test positive out of those that have the disease. Specificity, we are looking at the number who test negative out of those that do not have the disease. And then for the research questions, question 1, our population is those that do not have the disease. Question 2, our population is those that do have the disease. So this is the information that we will need as we work our way through the project. So scrolling down to the actual information we have, the study that was done, that we had a random sample of 1,000 individuals, and I split that into 2 separate groups. So we have 245 who actually have COVID-19 for our first group. So this 245 who actually have COVID-19 that is our population that does have the disease. So this is what we wanted for question 2. So this information is for question 2 versus the 755 identified as not having COVID-19. That population is those who do not have COVID-19. So this is the information for question 1. So as we go through this project, again, the second bullet point is giving us all of the information for question 1. The first bullet point gives us all of the information for our sample for question 2. So if we look at question 1, we're trying to find a confidence interval for finding the specificity. And again, specificity is essentially the proportion that test positive out of those that have the disease. So, sorry, specificity is the proportion that test negative out of those that do not have the disease. We're using our sample, has 755 who do not have the disease. So that would be our N. Our P hat, we have 683 test negative out of those 755. Again, for specificity, that is precisely what we want. We want the proportion that test negative out of those that do not have the disease. So in this case, our P hat would be 683 divided by 755. For the second question, we're looking at sensitivity. Again, sensitivity, we're looking at the proportion that test positive out of those that have the disease. So in this case, our sample size, we're looking at the first bullet point. We have 245 individuals that have COVID. Out of those 245, we had 237 out of 245 test positive. So that would be our P hat. So your job essentially is to take this information and find the appropriate confidence interval or hypothesis test. Again, sensitivity, we're looking at, sensitivity, we're looking at the number that test positive out of those that have the disease. And this is the proportion who test positive out of those with the disease. I will move the bottom box in just a moment. I apologize for the overlap. So moving this one, there we go. Specificity, we're looking at the number who test negative out of those that do not have the disease. This is the proportion who test negative out of those without the disease. So these are kind of, this is all of the sort of relevant information for what you need in order to answer the research questions by finding a confidence interval and a hypothesis test. So that is project 5. Again, your job is then to find the confidence interval, find the hypothesis test, or run the hypothesis test, following the steps that I list out. So I'm going to go ahead and erase this side. Our job is to then do a paragraph answering research question 1. Research question 1 was a confidence interval. And then research question 2, our job is to run a hypothesis test. And I have listed all of the information that I would like you to include in each of those. So that's project 5. If you have further questions, feel free to shoot me a message.